right, so determine the functions are below are continuous. If discontinuous, identify the type. So this guy is discontinuous, but why? It's because it's jump and it's at x equals 2, so watch out for those. It's going to go straight across here. This guy right here, definitely continuous. This guy is discontinuous, but it's infinite. What am I doing with this? This is too hard. This guy is discontinuous, but remember this infinite, or we can just label it as an asymptote, okay? And it's at x equals 3. This guy is discontinuous at that point. You can see that open circle there, so watch out for that. That is called removable, or it's called point discontinuity, okay? Now these guys right here, what I wanted to do is I'm just going to discuss them real quick, the steps. So here, you know what? No, I'm not. Why don't I just go ahead and do this and just do it row by row, because it's too hard to have the two sheets. To subtraction, you can see the G subtracting the H, distribute the negative sign, got that. Here, one over top the other, so this, we've got this whole function here over this, so therefore you could, if you divide by a fraction like that, then this guy actually is multiplying by the numerator, so those guys would go up to the top. Then you would, oh no, this is factored. Okay, so they factored the difference of two squares there. Then, when they multiplied by the fraction here, they were able to cross out one of them, and they're left with that. But notice this guy. This is an x cannot equal -1. So it's a disclaimer that says if you ever have one of these guys, always watch out for that, because you cannot divide by 0. So it's always kind of a pain in the neck. So don't forget about that guy. Here we've got two functions multiplied to each other. No biggie. Looks like they factored both of them. And the x plus 1 did cancel out, so you were left with these two multiplying to each other, and that just formed a cubic polynomial for 4 terms. This one right here, you've got division. Nope, you've got addition. So because this guy's a fraction, we had to give him an x plus 1. And so we gave him an x plus 1, and that ended up being multiplied out. So now we can combine those two, and again, you cannot have x equaling -1, and so they just added those two. You can pause this whenever you'd like. Now here we've got the g function being composed with h, so h composing g. So the g function got put inside the h. The h is just 2x minus 1, so the x basically opens up its window, and the g function goes right inside. Go ahead and distribute that and combine the -10 with -1. Here we're putting the h function, the line goes into the rational function, so you're just going to basically FOIL that out, okay, and then distribute, see what happens, and nothing happens because you cannot divide any of those by 2. You can't divide all of them by 2 because of 3. And just make sure that you say that x can't equal 0, because that would produce a 0 in the denominator. Here's another one. Looks like we've got two functions. Oh, we're evaluating now. So evaluation, the h will have the -2 put in, and then the -2 will go into the g, okay, because that's what that means. The only time this doesn't happen is when you have the composing. If you compose it, you got to put the 3p into the g first, get that, and then put it into the f. So I'll just leave those here for you to see. Pause it whenever you'd like. You can just see the outputs. You're supposed to just add those together. So adding the two outputs together. Looks like we got an absolute value. So the f, g, and the h's have all changed for these 3 problems. Looks like we've got this 4y minus 3 gets put into the g. Get that. Okay, annoying. This guy goes into the f. Kind of annoying, but doable, not too hard. And then you just simply add these two results together. And that's this guy. Next, this guy, if you put the 3p into the g function first, you're going to FOIL that out. You're going to get, not FOIL, but just evaluate. You get this expression. This expression now will go into the f function. So composing is a very special function, function in functions. This guy goes into the f function so that you get right here 2 times that function plus 7 2 times that function plus 7. So that's our result. All right. Okay.